so the next lecture is like a small tutorial on PyTorch. And what I will try to cover is first some of the basics of PyTorch, and then how we can use this framework to train your model. So the training process we already discussed, like the high level, the conceptual idea behind it, but we will look into like the code, the specific code which is used to do that. And later in the tutorial, you will see, which will be like hands-on tutorial, you will see like the actual code running for that process. Okay, so let's start with the basics. There are like a lot of deep learning libraries out there, and again, this is just a very small list. And daily, you will see like different frameworks are being developed for different applications. And so we have Torch, we have PyTorch, TensorFlow, you might have heard of. Then we have Theano, and I'm not sure if like people still use Theano. And again, these are all variants. So PyTorch is something like which is considered like the easiest to follow because it's based on Python, and it's like I think it has a very good documentation as well. TensorFlow, it's very powerful, but again, if you don't have expertise in deep learning or coding, then I think you will struggle a lot. So in that sense, I think the PyTorch is something which has a very like you will say like a non-steep learning curve. Okay, and that's why we chose PyTorch. And we have said it earlier, it's up to you if you want to use a different framework. If you have expertise, perfectly fine. But then like whatever tutorial we are going to have, whatever help we'll provide, it will be mainly focused on PyTorch. And that doesn't mean we will not help you with other frameworks, we will, but that could be like limited and maybe not as extensive as PyTorch. Okay, so in PyTorch, we have tensors, and these are same as like you use NumPy arrays. Okay. The only difference is these tensors can also be used on a GPU. And why we need GPU? Because we want like faster computation. If you don't use GPU, you just use your CPUs for training, it will take a lot of time. And you will experience that when you're doing your programming assignment too, like the difference between CPU and GPU. So these GPUs are usually people used to develop these for like playing games and video rendering and all that. But these days, you all know that they are very useful for training these deep learning models. And the reason is like they have like very optimized computations, matrix multiplications, which makes the computation very fast. And I think so far I think you must understand that inside your network, whatever you do, it's most of the time it's like matrix operation, right? You're multiplying matrices, you are adding matrices, subtracting matrices. So we have like very optimized code for that in for GPUs. And I think CUDA is a library which actually enable that. So let's try to understand like what are different variables available in PyTorch, how they relate to like what you have in NumPy, and how they can be useful. So first of all, if you're using PyTorch, you will have to import this torch library. So that's a standard you do in Python as well. If you want to create a random matrix, and this matrix could be like 1-dimensional, 2-dimensional, or multiple, it can have any dimensions. So you just call this function torch.rand, and 2x3, it's just telling you the shape of that matrix, right? So this is like a 2x3 matrix. This is a 3x3 matrix. And like Python, you can also just print these values, and it will give you like what is stored in these variables. Okay, so this so far so good. It's pretty simple, the way you do in Python as well. The only difference is like how you actually initialize these. Okay? These will give you like tensors in the form of matrices. Now let's say if you want to create like a array or a matrix which has all zeros. Again, you can do dot zeros. Again, this is same as you do in Python or using NumPy. And you give the shape. Okay. You can also initialize your tensors directly from data. And the way to do that is you use like this tensor API, and you give the values. And this is going to create like a 1-dimensional vector which has these two values. Okay, and this is like I think pretty useful when you're actually creating or you're designing your architecture. You need to debug like, okay, what's the size of the tensor at this point of time? So this variable or tensor.size can give you that value. And again, this I think function you also have in NumPy.